Hey folks, welcome to our first asynchronous lesson. So, we're going to look at polynomial long division today. I know that the last time you saw long division was probably quite some time ago. We're going to go over a really quick example of that. Then we're going to take a look at two examples of long division with polynomials and how to check them using Desmos. That way, do all this work and you're good to go. Before we get started, watch out for negatives. That is an insanely important thing to do. Watch out for the negatives. Second, it looks like a long process. It's just the same thing repeated over and over and over. So, without any further ado, let's get started. You might be looking at this screen saying, no, he did not just do that. But I did. And there's a reason why. For polynomial division, it really helps to go back and do a review of long division, the way that you learned all those years ago. So, let's set it up. We have our little house. We got the 100, we got the 7. Silly question, but how many times is our 7 go into 1? 0. 0 times 7 gives us this. Subtract it. And then you bring down this. How many times does 7 go into 10? Once. Let me move that. So you do 1 times 7, and you get 7. You do your subtraction. You're going to get 3. Then you bring down your 0. Well, then you ask yourself, how many times does 7 go into 30? 4 times. 4 times 7 is 28. You do your subtraction, you get 2. So our answer here is 14, remainder 2. Now you might be asking why we just did a blast to the past from like 5th grade. The reason why is we're now going to do this with polynomials, and you're going to see a very similar process. Let's take a look. Polynomial long division. You'll see a lot of the steps are the same. You still set up long division. You still complete each step before you do the next. Here, instead of just checking by plugging into a calculator, we can check by using Desmos. If it's the same thing, the graph should be the same. Let's move this on up here. Okay, let's set up the long division. So I'm going to set it up. Got to put this part over here. All right. Now our goal in each one of these is going to be to get rid of the first term first. So I'm going to see how many times I need to multiply this r to be r to the third, and what I need to multiply it by. Well, the answer there is going to be r squared. And then I just bring it down. I'll multiply the r squared by this bit and put that here. R squared times r is r to the third. R squared times minus 5 is minus 5r squared. And then, just like normal division, we subtract. R squared minus r squared is 0. We don't have to write it. Negative 7 minus negative 5 is negative 2r squared. Then we bring down the next bit, plus 13r. Then we ask ourselves again, well, what do I need to multiply r by to get negative 2r squared? Well, I need to multiply it by negative 2r. So I'm going to do negative 2r. Well, negative 2r times r is negative 2r squared. Negative 2r times negative 5 is positive 10r. And then I'm just going to subtract, same as I did before. First two terms are going to cancel out. They always will if you're doing this right. So I'll have 13 minus 10. So that's just going to be 3r. Bring down the next one. Minus 13. Well, then we're just going to ask ourselves, this r times what is this 3r? The answer here is just going to be 3. So I'm going to do plus 3. Well, 3 times r is 3r. 3 times negative 5 is negative 15. And I'm just going to subtract it. 3r minus 3r is 0. I'm not going to do anything with it. Negative 13 minus negative 15 is positive 2. So we did it. Now, here's the part where it looks wonky, but it's literally the same thing we just did. Our answer here is r squared minus 2r plus 3. I'm going to say 2 over r minus 5. I got the r minus 5 from what we're dividing by. That's where it came from. And actually, it's the exact same thing that you've done in the past. It's just another way of writing your remainder 2. You could put this is 14 plus 2 over 7 instead. All this way of writing it is saying is it gives us a nice easy way to graph it. And let's check how to graph it with Desmos to make sure it's right. Desmos, what I've done is I typed in up here the first part that we had. That was the first part right up here. I replaced all the r's with x's just because that way Desmos knows what to graph. And I click it. Boom, it pops up. Here's our weird looking graph. It's a very strange looking. That's okay. Now, if you're looking at your computer keyboard and thinking, I have no idea how to type a division symbol like that, that's perfectly all right. I had to look it up too. And you don't need it actually. You can just type it like this. Now, you'll notice these are the exact same one. They overlap each other completely. Just keep in mind, if you're using the division symbol like this, they're not the same thing if I don't have the parentheses. The parentheses as a grouping symbol are incredibly important. Either way, what we should have if we type in this, which is our answer, we had it right here, is we should have the exact same graph. All of this should be overlapped in the next color, blue. And it is. So we know we're right now. And you can check all of your answers like this. So you've seen the examples, you saw how we do it, you see how we check with Desmos. Give that delta math a shot. When you come back, we're going to talk about something called synthetic division and the remainder theorem in the second video, but right now I just want you to have experience with polynomial long division. Go for it and give those a try.